Good afternoon. In today's session, we have to see about hybrid, inverse hybrid, and ABCD parameter. So we know we are using here two-port network. So two-port network is nothing but a network which will consist of two pairs of the terminal. We can call that network as the two-port network. Here you can see in this circuit diagram, we are calling this network as a two-port network because one port, it means what? One port is having one terminal at which current is ingoing, and the other terminal, the same amount of current that will be outgoing. So here in this two-port network, we are supposed to study about the hybrid parameters. If in the two-port network, the value of voltage of port 1 and the current flowing through port 2 are the dependent variable, then we can call that network as the hybrid network. Here you guys can see the value of V1, that is voltage appeared across port 1, and the current flowing through the port 2 are these are the dependent variable, and these are depending on the current 1 and voltage across port 2. So here we can say in the hybrid network, V1 and I2 are the dependent variable and I1 and V2 are the independent. If you build the equations for two-port network in terms of hybrid parameter, you will get the equations V1 equal to, that will be the function of I1 and V2, and I2 will be the function of current which is flowing through port 1 and the voltage which is appeared across port 2. We can write these equations in the form of H parameter. These are nothing but the hybrid parameter. So if you are writing, you can write V1 equal to H11 into I1 plus H12 into V2. We can call this equation as 1. Again, you are supposed to write the equations for the dependent variable I2, current flowing through the port 2. You can write I2 equal to H21 into I1 plus H22 into V2. You can write these linear equations in the form of matrix form. If you are writing these equations, you can see we will get the equivalent circuit for this hybrid network. Here we are calling V1 as a dependent and I2 as the dependent variable. So V1 is nothing but the voltage appeared across port 1. So here if you see the equivalent circuit, port 1 network is like a Thevenin equivalent circuit, because this is nothing but impedance, resistance. We can call it is here as a hybrid H11. So we can say this circuit diagram, port 1 is looking like a Thevenin equivalent circuit. And again, you can see here I2 is also a dependent variable. It is current flowing through the port 2. So here port 2 will behave as a Norton circuit. So here you can see we will get H parameter that will be in parallel with the value of current. That will be in parallel with the value of current. So here we can say we have to derive the H parameters value by using this equivalent circuit. Okay, so you can see here. Now we have to see one example for the H parameter. According to H parameter, we know the value of V1 and I2 are depending on I1 and V2. So you will get the four equations because you are supposed to derive the H parameter. You are supposed to derive H11, H12, H21 and H22. So what we can do? We can consider one dependent variable as 0. हम क्या करेंगे, पहले V2 को 0 वोल्ट कंसीडर करेंगे, then next time we can consider I1 equal to 0 ampere. If you are considering I1 equal to 0 ampere, you will get the equation for H12 and H22. And whenever you are considering V2 equal to 0, at that time you are getting the equations for H11 and H21. These equations will be needed to solve numericals dependent on H parameter. So here They are giving us one equivalent circuit and we are supposed to find the H parameter. These are nothing but the resistors. We can call these are as the H parameter. What we are supposed to do here? We are supposed to find H parameter by using these four equations. So here to find H11 and H21, you can see here when we are supposed to find H11 and H21, at that time we have to consider V2 equal to 0 volt. So what we can do? We can consider पोर्ट 2 एज अ शॉर्ट सर्किट. हम ये पोर्ट 2 को क्या करेंगे? शॉर्ट सर्किट कंसीडर करेंगे. सो वी कैन कंसीडर पोर्ट 2 एज अ शॉर्ट सर्किट एंड अप्लाई करंट I1 which will be flowing in port 1. So here we can calculate H11 and H21. We know if we are supposed to derive H11, we are having the formula H11 equal to V1 upon I1. We are not having the value of voltage and current, so we can convert V1 in the form of I1. हम क्या कर सकते हैं? वोल्टेज को करंट के इक्वेशन में लिख सकते हैं अकॉर्डिंग टू ओम्स लॉ. व्हाट विल बी इक्वेशंस? The resistance, total resistance into I1 upon I1. I1 will get cancelled and total resistance कैसे मिलेगा तुम्हें? You can see here 3 and 6 will be parallel and they are in series with 2 ohm. So you can calculate 3 into 6 upon 3 plus 6. 18 upon 9. That will be 2. 2 plus 2, you will get H11 as a 4 ohm. Again, you can calculate the value for the H21. स्नेहा आवाज आ रही है अच्छी से? स्नेहा? Okay, so you can see here, now we have to derive the value for H2. How we can derive? Again, we are having the formula I2 upon I1. But here also we didn't know about the current value. But how we can do? We can convert I2 in the form of I1. How? By using the current divider. So how we can convert? We are supposed to derive I2 which is flowing through the 3. So we can use current divider rule. The parallel resistance, that will be 6 upon total resistance, 6 plus 3, 6 upon 9, that we can write as a 2 by 3. 2 by 3 into I1 upon I1. I1 will get cancelled and you will get 2 by 3. But that value will be negative because you can see when we are using the current divider rule, at that time I2 is going to this side and I1 is coming to this side. These are having different directions. So here whenever we are calculating H21 and we are converting I2 in the form of I1, you are supposed to convert that equation as I2 equal to minus 6 upon 6 plus 3 into I1. That's why I have written here minus 2 by 3. Now we are supposed to find H12 and H22. How we can derive the H11 and H12? Again, we can use our formulas. You can see here, we are having the formula for H12 as V1 upon V2. But when the value of current I1 will be 0. Now we are supposed to consider I1 as 0 ampere. That's why to find H12 and H22, we are supposed to make port 1 as a open circuit. जो सर्किट है उसको क्या करेंगे? पोर्ट 1 we will consider as open circuit and we will apply voltage across port 2. So now our equations will become H12 equal to V1 upon V2 when I1 will be 0 ampere. So we are not aware about the voltage value. We are not having the value of voltage. But what we can do? We can write this equation in the form of current. How we can write? IR. IR will get cancelled and you will get in the form of resistance. Again, we know we can use the voltage divider rule. So according to voltage divider rule, if we are having the total value voltage V2, तो हम V1 को क्या लिख सकते हैं? V1 we can write as V2 total voltage into 6 upon 6 plus 3 into V2. So what will happen? V2 will get cancelled and you will get H12 equal to 6 upon 6 plus 3 as 6 upon 9 and you will get 2 by 3. You can give ohm unit because this is also one type of resistance. Now you can calculate H22. How you will get the value for H22? We are having the formula I2 upon V2. Now we can convert V2 in the form of IR. How? According to the Ohm's law. We know V2 will be V2 will be across 6 ohm and that I2 will flow through 3 and 6 ohm. So total resistance will be 3 plus 6 into I2. तो हम क्या लिख सकते हैं H22 equal to I2 upon V2. I2 will be as it is and V2 I can write 3 plus 6 into I2. So I2 will get cancelled and you will get 1 upon 3 plus 6. That will be 1 upon 9 ohm. You can give the unit for the H bar. Now we are supposed to see about the inverse. Inverse hybrid parameter. That will be exactly opposite with H parameter. So here in hybrid parameter क्या था? The V1 and I2 are the dependent on I1 and V2. Here exactly opposite. I1 and V2 are the dependent variable and they are depending on V1 and I2. So you can write in the form of equations. You will get equations as you will get V2 equal to, you know, here value of current and current which is flowing through port 1 and the voltage appeared across port 2 are depending on I2 and V1. So you can write here I1 equal to G11 V1. It is nothing but H11 dash inverse of H11. So we can call it is as a G11. G11 V1 plus G12 I2 equal to 1. I can give this equation as a 1 number. Okay, you can give this equation as a 1 number. And you can write V2 equal to G21 V1 plus G22 I2. So now if you see the equivalent circuit exactly opposite with hybrid parameter, here port 1 will look like a Norton's equivalent circuit and port 2 will be look like as a Thevenin equivalent circuit. So if you are supposed to derive the value for G11 and G12, G11 and G12, at that time हम क्या कर रहे थे यहाँ पे in hybrid parameter whenever you are deriving H11 and H22 we are making port 2 short circuit. So here we are supposed to make circuit open. Whenever you are supposed to calculate G11 and G12 you are supposed to make port 2 as a open circuit. And whenever you are supposed to calculate G22 and G21 at that time you will make port 1 as a short circuit. Exactly opposite with H पैरामीटर. हम यहाँ पे ओपन सर्किट कर रहे थे पोर्ट 1 को, तो हम क्या करेंगे पोर्ट 1 को शॉर्ट, बिकॉज हियर पोर्ट 1 will behave as a Norton and port 2 is behaving as a Thevenin. So here now we have to see about the ABCD parameter. So in ABCD parameter we can call this network as a T network, we can call this network as the chain parameters, because here the value of V1 and I1 are depending on V2 and I2. यहाँ पे क्या है voltage which will appear across port 1 and current which is flowing through port 1 depending on port 2. ये port 2 का जो port 2 के across जो voltage है वो port 2 से जो current जा रहा है उस पर depend है. So we will get the equations V1 equal to F, this is the function of V2 minus I2, and you will get the equations I1 that will be of function of V2 comma minus I2. We are taking here current negative. So here if you are calculating you are converting these equations in the form of ABCD. You can write these equations in the matrix form, or you can write these equations in the form of linear equation, and you can convert these equations in the form of ABCD to get the equations for ABCD parameter. हमें क्या चाहिए यहाँ पे ABCD parameters के value चाहिए. So how we can convert? You will get equations V1 equal to. Please Priyanka mute yourself and please join the class on time, because you have missed about the hybrid inverse hybrid parameter. Okay, so see here, now we are studying here ABCD parameters in which we are using two port network. Two port means it will have two port, two terminal at port 1 and two terminal at port 2. So here if you see, the voltage appeared across port 1 and current flowing through port 1 are depending on voltage appeared across port 2 and current flowing through port 2. So you will get these two equations. So we can write these equations in the form of matrix. And we can say this network as a transmission line network, or we can say this network as a chain network. And value of I1 and V1 is depending on I2 and V2. You can convert these equations in the form of ABCD. What you are supposed to consider? You are supposed to consider first current flowing through port 2 as 0 ampere. So you can make that circuit as a short circuit. And you are again consider that circuit as an open circuit to calculate the value for B and D. You can consider that circuit as a short circuit and V2 will be 0 volt. You will get the equations for B and D. मैंने क्या किया है, ये जो दो इक्वेशंस मिल रहे हैं ये V1 और I1 का, ये इक्वेशंस में फर्स्टली आई एम कंसीडरिंग I2 इक्वल टू 0 एम्पियर. So you will get V1 equal to A into V2. So you can convert that equation in the form of A. A का value क्या हो जाएगा? A will be V1 upon V2. Again, in second equation, if you are considering I2 equal to 0 ampere, your equation will become I1 equal to C into V2. You can write this equation in the form of C. C क्या हो जाएगा? I1 upon V2. Again, if you are considering I2 equal to 0 ampere, ये second equation. If you are considering, firstly you have considered I2 equal to 0. Now if you are considering V2 equal to 0, your equation will become V1 equal to B into I2. So you can convert that equation in the form of B. You are taking here positive value, तो मैंने minus I2 को यहाँ plus I2 I have written, because you are supposed to calculate the values for the ABCD parameter and you can take this value in the modulus form. So you can take this value as a positive. If you see the example for the ABCD parameter, these are nothing but T parameters. You can see we will require these four equations. We will require only these four equations A, B, C, D. To calculate value of A and C, we are taking I2 equal to 0 ampere. And to calculate value of B and D, we are taking V2 equal to 0. So if we are having that circuit and we are supposed to calculate the ABCD parameter, you can see here A is nothing but V1 upon V2 and current flowing through is 0. So you will get A equal to V1 upon V2 and voltage will be same, because you can see here this circuit is an open circuit. तो क्या हो जाएगा? वोल्टेज सेम रहेगा. सो यू विल गेट V1 अपॉन V1. V2 मतलब सेम हो जाएगा. सो यू विल गेट A इक्वल टू 1. इफ यू आर कैलकुलेटिंग B मतलब क्या है? V1 अपॉन I2. But we know V by I is nothing but R is nothing but impedance. Impedance means here we are having the value for impedance as Z, because voltage will be same. तो I2 को मैं क्या लिख सकती हूँ? V1 into Z. V1 will get cancelled and you will get here impedance that will be Z. So here B you will get as a Z. If you calculate CD, you will get C equal to 0, D equal to 1. Again, if you see another circuit, if you see this circuit, how you will get? You can see here this is the short circuit. We have taken here open. So what will happen? If you are calculating A, it will also becoming 1. If you are calculating B, it will become 0. If you are calculating C here, it will become Y, because it is nothing but the Y impedance we are using here. And C का इक्वेशन क्या है हमारे पास? I1 upon V2. So V को तुम क्या लिख सकते हो? IR के फॉर्म में लिख सकते हो. So you can write C as a Y. C equal to Y. If this is complicated circuit, you guys can see here the last one circuit. What we are supposed to do? We are supposed to use that two-port network because this is also a two-port network. At incoming, we are having the port and here also another. What we are supposed to do? ये Y parameter wala circuit, Y. These circuits are different. Z and Y, these are different circuits. 1, 2, 3. This is the fourth, and this is the fifth circuit. You can see here the fifth circuit. What is happening? You are supposed to calculate the value for ABCD. If you are calculating for A, we are having the formula V1 upon V2. But if you see about the V1, so you know you are supposed to calculate here V1 for this port and for this port also, for Y1 and Y3 also. If you are calculating, you will get A equal to 1 plus Y2 upon Y3. 1 plus y2 upon y3, because when you are calculating the value of a, you are supposed to calculate a, that is nothing but v1 upon v2, considering I2 equal to 0 ampere, and here we are having the y values 3 times. So we are supposed to consider all these. So you will get c equal to y1 plus y2 plus y1 into y2 upon y3. These are the example for the T parameter. Now we can see inverse ABCD. It will also similar with ABCD but only exactly opposite in terms of here वहाँ पे क्या था in ABCD the value of V1 and I1 are depending on V2 and I2. यहाँ पे क्या है the values of V2 and I2 are depending on I1 and V1. The same equations बस V2 की जगह वहाँ V1 था तो V1 की जगह यहाँ पे V2 है, और जब वहाँ पे I1 था I1 की जगह पे यहाँ पे I2 है. So here you will get the equations V2 equal to the function of V1 comma minus I1. You can write these equations in the form of matrix also. You will get the equations for A dash, B dash, C dash, D dash. Only what we are doing here, instead of V1 and I1 dependent, we are considering here V1 and I1 are independent, and we are taking V2 and I2 as a dependent variable. So you will get these equations. Now you can see we can interrelations between these parameters. It means what? We can convert any parameter into the other parameter, because we are having the formulas for H parameter, Y parameter, Z parameter, ABCD parameter, inverse ABCD parameters, and inverse hybrid parameter. We are having the 6 combinations, and we are getting the equations for all these dependent variable. In H parameter, V1 and I2 are the dependent. In inverse hybrid, V2 and I1 will be dependent. In Y parameter, the value of I1 and I2 is depending on V1 and V2. In hybrid, the value of V1 and V2 will depend on the I1 and I2. If you see, Z is exactly opposite with Y parameter. H is exactly opposite with inverse hybrid, and ABCD is exactly opposite with inverse ABCD. So what we are supposed to do? We are supposed to consider, we are supposed to study 3 thoroughly. तुम क्या करो? Z पैरामीटर पढ़ लोगे तो तुम्हें Y पैरामीटर आ जाएगा. What is the difference? Instead of Y, we are supposed to take here Z. Instead of current, we are supposed to take here voltage, और voltage की जगह current लिया है. सेम इन इनवर्स हाइब्रिड पैरामीटर. हाइब्रिड में क्या ले रहे हैं? वी आर टेकिंग V1 एंड I2 डिपेंडेंट. सो V1 एंड I2 हम यहाँ लिखेंगे, एंड I1 एंड V2 यू विल टेक हियर. सो दैट विल बी योर इनवर्स हाइब्रिड. और H की जगह वी विल यूज हियर G लेटर, G11, G12, G21, G2. इक्वेशंस विल बी V1 और I2 की जगह यहाँ पे तुम्हें इक्वेशंस मिलेंगे फॉर V2 एंड I1. Again, if you see, So what we can do? We can convert here any type of parameter into the other, and the derivations proofs are not expected to study in our syllabus. Only we will needed this formula how we are converting. What we can do? We can take the 4 by 4 matrix. क्या लिया है मैंने 4 by 4 matrix लिया है. I have written here first y, first row, first column y, second row, second row, second column Z. Third row, third column I have taken as H. Fourth row, fourth column, T is nothing but transmission. We can say this is the ABCD parameter. I have used here instead of ABCD, I have used here T. So these are nothing but the transmission. So we will get the equations for Y, Y11, Y12, Y21, Y22. If you are converting Y into Z, you will get these equations. You are converting Y into H, you will get these equations. You are converting Y into 2, you will get these equations. So these are the differences. जहाँ पे H है, you will get H11, H12. If you are transmitting here, you will get T11 is nothing but A, T12 is B, T21 is C, and T2 is D. I have written in the form of T. A T is nothing but these are ABCD. H parameters. G are nothing but G is nothing but the inverse. But I have used here only Y, Z, hybrid, and the transmission. We are not taking here inverse concept. Inverse hybrid we have not taken, and inverse ABCD also. So what we can say, to find the all two port networks, we can convert any parameter of the network into other parameter. We can convert this. You can see whenever we are making the interconnections between two port network, means instead of one network, if we are using their another network, if we are interconnecting two port network, you can see here we can connect Y network parallel with each other, and you will get equations. If two networks which are parallel with each other, two port network, both are also a two port. Here you can see, here is YA. If you see the circuit diagram for YA, you can see it is also having a port, and it is having output port. Also, it is having two port. We are calling this port, and this is also a port. So if we are interconnecting two port network, at that time you will get the Y parameter if they are in parallel, and that value of equivalent Y will be the addition of these two, and we are taking this value in the modulus form. So we are considering this value as a positive. If there are Z parameter, we are taking the Z parameter which are in series. You can see one is interconnected with other directly by using a wire. So we can say ZA and ZB, these two port networks are connected in series with each other, and if you calculate the equivalent Z parameter for this series network, you will get Z equal to ZA plus ZB. And ABCD parameter, already we have seen about ABCD. We can call ABCD as a chain parameter. Chain means what? We can make cascade. We can connect one by one. We can connect lots of. So we can call this ABCD parameter as a cascade parameter. And if you are calculating, you are supposed to derive equivalent transmission parameter for the ABCD, that will be multiplication of all these cascading terms. So if we are having two terms TA and TB, so total equivalent transmission will be multiplication of TA into TB. Derivations will be not needed here. So just why I have given here how the Y parameter will be interconnected, how Z parameter and the transmission parameter will be connected. Transmission we can call as a cascade. Z parameter, if there are lots of Z parameter connected, we can say that will be connected in series. And if Y parameter, we can say this will be connected in parallel with each other. So series connections we will see in next class. Now we will revise our this session. So in today's session we have seen about the hybrid parameter. We can say two-port network as the hybrid network if value of voltage appeared across port 1 and current flowing through port 2 are the dependent variable. I2 और V1 यदि डिपेंडेंट वेरिएबल है तो तब हम उस नेटवर्क को क्या बोल रहे हैं? We can call that network as the hybrid network. And we will get the value of V1 and I2 in the form of I1 and V2. And according to these equations, we can convert these equations, linear equations, in the form of hybrid parameter. H11, H12, H21, H22, we can convert. How? We can consider one independent variable as a 0 volt or 0 ampere. If there is a value of V2, we can consider V2 as a 0 volt. If you are considering V2 as 0 volt, you will get the equations for H11 and H21. The same equations I have used. ये जो दो equations है 1 and 2 I have used to derive the value of these. Or we can make these equations from this matrix also because all are having the same meaning. We can write in the form of linear equations. You can write in the form of matrix. And this is the equivalent circuit. Port 1 will behave as Thevenin and port 2 will behave as a Norton equivalent circuit. If we want to see inverse hybrid parameter, it will be exactly opposite with hybrid. We can use hybrid ki jagah, we can use their G letter, G parameter. We can say it is the G parameter or the inverse hybrid parameter. And here the value of current flowing through port 1 and value of voltage appeared across port 2 will be dependent. So we will get the equations of V2 and I1 in the form of V1 and I2. So again you can consider here I2 equal to 0 ampere or we can consider V1 equal to 0 volt. So you will get the equations for G11, G12, G21 and G22. I have not written here but we can make these equations. If you are considering here I2 equal to 0 ampere, you will get G21 equal to V2 upon V1. Again, if you are considering I2 equal to 0 ampere, you will get G11 equal to I1 upon V1. Accordingly, you can make the equations for G12 and the G21. Now, ABCD parameter. If we are having the two-port network in which voltage appeared across port 1 and current voltage appeared across port 1 and current flowing through port 1 will be dependent on voltage appeared across port 2 and current flowing to port 2, we can call that network as the cascade network. We can say that network as the chain network or we can say this network as a transmission. And you will get the equations of ABCD by using these two linear equations, equation 1 and equation 2. You can write these equations in the form of matrix also. You can consider I2 equal to 0 ampere or you can consider V2 that is nothing but independent voltage as a 0 volt. You will get the equations for A, B, C, D. We can see these examples for the T parameter ABCD. Now, what we can say, if the value of V2 and I2 are dependent and on V1 and I1, we can say that network as the inverse ABCD network. And we will get the equations in the form of A dash, B dash, C dash and D dash. We can calculate the value for A, B, C, D dash parameters by using these two equations. ये V2 का और I2 का equations use करके we can get the equations for the A dash, B dash, C dash and D dash. We can convert any transmission parameter, ABCD parameter, Y parameter, Z parameter into other. These are the expressions for all the parameters and we can express this parameter in any other parameter. We require only these equations and we can convert these equations as shown. And here the derivations will not be needed. So we can take here Y parameter and you can convert Y parameter into Z as. We can convert Y parameter into H parameter like this. You can convert T parameter into Z like this. How we can say to find the all two-port network parameter for a single network, we can convert any parameter into the other parameter. If there is a interconnections between two-port network, if there is a Y parameter, that network will be connected parallel. If there is a series network, we can say we can calculate the Z parameter by using that series network. We are supposed to take additions of all the impedance flowing across each network. मतलब जो impedance है at each network we are supposed to take addition if they are in series, and if there are lots of transmission port network and that will be cascading with each other, we can take T equal to TA into TB. You will get the cascading network. Here we have finished about interconnections of the two-port network. In next class, we have to study series and parallel connections. How we are doing the serial and parallel connections. We will see in next class. If anyone is facing any issue, you can ask me. सबने टेस्ट दे दिया है इलेक्ट्रिकल सर्किट का? If anyone has not given, you can give. If anyone is facing any issue, you can ask me. Sneha, Priyanka?
हाँ मैम.
Okay, you are supposed to do practice at home also. That time you will get the things because there are the numericals in electrical circuit. मैं orally कितना भी बनाऊंगी, तुम practice नहीं करोगे तो समझ में नहीं आएगा. Okay, you are supposed to do, and if any issue then you can ask me. Okay.
Okay.
Okay. ठीक है, you can mute yourself. If anyone is facing any issue, you can ask me. Vishal?
Yes, ma'am.
Your voice is cracking. Okay, okay, हाँ, okay. You can mute yourself. हाँ, okay, okay. और lecture time पे attend करो सभी. Okay, ठीक है. You guys can leave now. Thank you. Remaining part we will see in next session. We can conclude our today's class.